Все, давай, тормозим кабана. Правильно работает. Проблема заключается в том, что на разных режимах работы Погнали!
Hello everyone, my name is Kirill. You are on the AutoAdviser channel. Due to numerous requests from our subscribers, we're finally filming a video about the variable valve timing system. The generally accepted international name for this system is variable valve timing. It is designed to regulate the operation of the gas distribution mechanism depending on the operating modes of the engine. But each automaker has its own name for this system. There are a lot of these names, but in each name there is the letter V, which stands for valve. By the way, for BMW lovers, the VANOS system is also included in this list. Let's look at the reason why it is necessary to use this system inside an internal combustion engine. And so, we have a camshaft on which there are cams. This shaft rotates and these cams directly act on the valves. These valves open and close at the appropriate points in time. The second important point is that the shape of these camshaft cams greatly affects the moment at when the valves open, and also what stroke these valves have. But as you can see, the shape of these cams cannot change, so the valves always open at the same time and always have the same stroke, regardless of the engine operating mode. But many of you would now ask, when the engine starts to rotate faster, the crankshaft also rotates faster, the camshaft as well rotates faster, and as it seems, the valves begin to open more frequently. Yes, they do open faster, but the moment of them opening relative to the position of the crankshaft remains the same. Let's do it again. It turns out that the shape of the cams is constant. The valves open at the same time and have the same stroke relative to the position of the crankshaft. That is, it turns out that at low speeds and high speeds, valves behave the same. The problem is that at low and high engine speeds, inside the combustion chamber, the ignition processes proceed at different speeds. Therefore, the moment of opening the valves at low and high speeds should be different. For example, at high speeds, the valves should open a little earlier than, for example, at low speeds, since at high speeds it takes more time for the combustion chamber to be filled with air. So the shape of this cam is a kind of compromise solution that is suitable for both low and high engine speeds. But in reality, the best solution will be some kind of variable system that will allow you to change the moment of opening the valves, the duration of its opening, and the course of its movement. And so, we approached the purpose of the variable valve timing system. It is actually designed to change depending on the engine operating mode, the valve opening time, their lift height, and opening duration. It turns out that this system uses, so to speak, an individual approach for low and high speeds. All this allows you to increase the engine torque, increase its power, and reduce harmful emissions into the atmosphere. Structurally, the variable valve timing system has several forms, but the most common systems use the camshaft rotation. Let me show you how this works. And so, we have this central cam. The camshaft rotates and begins to act on the valve, and the valve opens. What needs to be done to open the valve a little earlier? You can simply turn the crankshaft down a little, and the valve will open earlier. This is exactly how this system works. It just turns the camshaft a little, depending on the engine operating mode. And now the question, how can we turn the camshaft? Because it is connected by a rigid kinematic connection with the crankshaft. Structurally, either an asterisk or a pulley from a belt drive is installed on the camshaft in front, as in my case, something like this. A belt or a chain is put on there to connect this shaft with the crankshaft. That is, we cannot just intervene in this belt or chain drive and rotate the camshaft. This is what the hydraulic clutch was designed for. It is also called the cam phaser, and the design of this clutch itself allows you to turn the camshaft a little. Let's see how it works. This clutch as a whole consists of a housing that rotates together with the crankshaft, and let's call it a stator. Something like this. But there is also a movable part inside the clutch. This is the rotor. It has a certain degree of mobility. Oil is supplied to this phaser under pressure. Here we can see the chambers into which oil is supplied. Here is the chamber 1 and here is the second. How many are there in total? 4. There are also chambers inside the clutch. We don't see them now. For this, it is necessary to open this clutch up. So depending on to which cavity oil is supplied under pressure, the inner part is turned in one direction or another. Let's look at a specific example. Let's install our clutch on the camshaft. That's about how it is installed. As I already said, there is a hole inside this shaft, and then it goes to this clutch. There is a cavity, and depending on which cavity the pressurized oil enters, the clutch itself rotates slightly relative to the camshaft, and thus these cams rotate too. As the cams turn, the opening time of our valves also changes. Let's do it again to understand better. The clutch consists of a stator outside and a movable rotor inside that can turn a little. Oil is supplied to this clutch through the specific channels. Filling the VVT gear with oil unlocks its stationary pin and makes its two independent rotating parts, causing angular displacement between the input, chain and output camshaft, advancing or retarding the timing depending on what chambers are filled with oil. Since our camshaft is turned, the valve opening time changes. The variable valve timing system can turn a camshaft, which is responsible for the intake valves, as it is in our case. This clutch is from a 1.6 Renault engine. It is installed on a Renault Scenic or Logan. This clutch is installed on the camshaft, which is responsible for the intake valves, but there are also systems where there are two such clutches and both intake and exhaust valves are regulated. By the way, regarding BMW, there are VANOS and there are dual VANOS, which is responsible for the intake and exhaust valves. By the way, if you need a new clutch or a phaser, then be sure to visit the site of the AutoAdviser. In general, this system is controlled automatically. It has its own control unit, its own sensors that monitor the speed of rotation of the crankshaft, and some other parameters. There are also actuators in the form of distributors that move and supply oil to various chambers of this clutch, depending on the operating mode of the engine. I want to emphasize once again that I talked about the variable valve timing system, which is based on turning the camshaft. But there are also other design solutions. There are such interesting camshafts that have cams of various shapes, and depending on the engine speed, different forms of cams are put to work. By the way, in my opinion, Honda first developed such a system, and now there are very affordable ones, that are on the market. We shot a separate video about this. The link will be in the description. I hope that I explained a rather complicated topic to you in a very simplified way. So be sure to like and subscribe to our channel. All the best to you and see you soon.